should be able to see my screen. I've already assigned the homework for 6.1, 6.2, 7.1, and 7.2, and I've already assigned the test because I got the feeling that most of y'all already know the material, so y'all can go ahead and get the test done. I did take the bonus questions off. I figured you didn't need the bonus questions, so I took them off. So let's get started on 7.1 and 7.2. 7.1 and 7.2 is talking about the area under a curve. And we're talking about the area under a curve without calculus, of course. So we're talking about using the calculator to find the area under the curve. Area could also be probability, and it can also be percentages. So area under the curve, probability, or percentages. There's two types of curve. There is the uniform curve, which is a rectangle. And then there is the curve that we're going to be doing mostly, and that is the normal curve. Both of them have a volume, an area of 1 under the curve, because probability goes from 0 to 1. So the area under both the curves is 1. Okay? Find the area of a uniform curve. You're going to use length times width. Area of a rectangle equals length times width. So 1 is going to equal length times width. They'll give you one or the other, and you can find the length or the width depending on which they give you. The area under the curve is a little bit different because you have to use what we call the empirical rule to guesstimate. And then we use normal CDF to calculate. Now, of course, I'm going to show you how to do it, and I use the empirical rule to guesstimate. That way it checks my answer when I calculate it with normal CDF. You need to draw a picture first. Of course, half of you won't, but I'm going to tell you what you should do. You draw a picture first. You use the empirical rule to guesstimate, and then you actually do the calculation and check back with the empirical rule to see if the answer makes sense. Along with the normal curve, you have the 3 types of normal curves. You have the normal curve, meaning the normal curve, and the standard deviation looks like this. And that's what your picture, of course, that I told you to copy. That's what it looks like. And then you have skewed left, which all the data is on the right of center. And then you have skewed right, which all your data is to the left of center. So 7.1 and 7.2 is going to consist of the uniform distribution, normal distribution, skewed left, and skewed right. Now let's take a look at the normal, the uniform. And they're going to give you a uniform distribution is as follows. With a time of 55 minutes, or we'll go with 60 minutes. And they'll say something to the effect, a class lasts 60 minutes. What is the probability that the class will let out at 45 minutes. Okay, so that's the type question you'll see. Of course, the length, there's the length is 60, the height is 1/60th. So therefore, you want 45 minutes. 45 is right here. So the probability of letting out at 45 minutes is equal to 1/60th times 15, which is 15 over 60. And simplify and change into a decimal as needed. So that's how you do a uniform distribution. Now let's move on to the normal distribution. Normal distribution is second part of 7.1, 7.2. And you got two types of normal distribution. You've got one where the mean is equal to 0 and the standard deviation is equal to 1. Therefore, you're using the scale like a z-score scale. So 0, 1, 2, 3, -1, -2, and -3. And of course, they're going to ask you for the probability. Remember that probability is the same thing as area, same thing as a percentage. All three of those mean the same thing. So if I give you a question and I ask for the 50th percentile, that means the area is equal to 0.5000. The area, the percentile, the probability, they're all the same. So I just want you to be aware of that, but most of y'all probably already know that anyway. And the second type is a normal distribution. Again, with the standard deviations, but this time mu is equal to 100 and the standard deviation is equal to 25. And therefore, instead of 0, 1, 2, and 3, you have 100, 125, 150, 175, 75, 50, and 25. Here we got to know the z-score is equal to x minus x bar over the standard deviation. You got to remember that when you're talking about mu is equal to a number greater than 0 and the standard deviation is a number greater than 1. So these are your two type questions that you're going to see in 7.2. Okay? So let's look at an example of both of these. And let's say that you got an IQ score, or what is, let's go with something simple. What is the probability that your score is going to be above 1.6 with a mean of 0 and a standard deviation equal to 1. So you draw normal curve, 0, 1, 2, 3, -1, -2, -3, and 1.6 is going to be right around here. So they want this area right here. Now, if we use our empirical rule, 1.6, 0, 1, 2, 3, -1, -2, -3. And 1.6 is going to be right in there. So that's 2.5 plus 6. 2.5 plus 6 is going to be like 8.5. So by the empirical rule, I'm thinking around 0.8500. No, 0.08. 8.5 is 0.0850. Or 8.5. Now we're going to do it by the calculator, and that's going to be 1.6. And y'all probably did this in your other probability courses. So let's go ahead and do normal CDF. So that'd be second vars, normal CDF, and we're going from 1.6 to 9999. And paste, and let's see what the actual area is. The actual area is 0.0548. So this area is 0.0548. So the probability that your score is above 1.6. So the probability that your score is greater than 1.6 is equal to 0.0548. And that is the answer to that question. So that's the type of question you have on a test. We'll do another one. Let's go ahead and do, what is the probability that your score is going to be between negative 0.6 and positive 1.8. So that's with a mean of 0 and a standard deviation of 1. So with our handy dandy picture, we're going to go with 0, 1, 2, 3, negative 1, negative 2, negative 3. And we want to know between negative 0.6, which is right there, and 1.8 would be right there. So by the empirical rule, we got, I don't know, let's say 17, 34, 51. Yeah, 51, and then another 13. So I'd say somewhere around 63, 64. So 0.6400. And with the calculator, we will do second entry. And let's see, that's going to be negative 0.6 and comma. Let's go with 1.8. 1.8. And I'm going to hit delete, 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 and enter. I came out with 0.6898. 0.6898. And that's the more detailed answer. But as you can see, it does tell you that you are close, because by the empirical rule, you've got 0.64. So the likelihood that you're going to fall between negative 0.6 and 1.8 is 0.6898. Now let's do one that has a mean of 100 and a standard deviation of 25. So we've got a mean of 100 and a standard deviation is equal to 25. And we want to find let's say these are IQ scores. And we want to find the probability of the IQ score, your IQ score, falling between 130 and 150. So that means we got to pull out our handy dandy curve. And that's going to be 100, 125, 150, 175, and negative, that's going to be subtract. It's going to be 75, 50, and 25. And we want to know between 130 and 150. And I'm going to say it's going to be around, by the empirical rule, it's going to be around 0.1200. So let's see, this is 120, we said 130, so that's going to be 130 minus 100 divided by 25. And this is going to be 150 minus 100 divided by 25. And 150 divided by minus 100 is 50, divided by 25 is 2. So we know that z-score is a 2. And 130, that's going to be 30 over 25, which is what? 6 over 5, which is 6 over 5. I don't know what that is. 6 over 5, which is, let's see, 6 over 5 is 1 and 1.3 or something like that. And there's your z-scores. So now we take our handy dandy calculator and we go from second vars, go down to normal CDF, and I'm just going to put in 5/6, or 6/5, just to make sure. 6 divided by 5, might not like it, and 2, and paste, and enter. I got 0.0923. So 0.0923 is your actual answer. 0.0923. Now, those are the two type questions that you'll see in 7.2. There's another one that we're going to go over. Those are the two questions. You got one where the mean is equal to a number and the standard deviation is equal to a number. And then you have the mean is equal to 0, the standard deviation is equal to 1. Now, here's another question you might have. IQ scores. I'm using IQ scores because the book uses a lot of IQ scores. IQ scores are as follows. With a mean of 100 and a standard deviation equal to 10. Find the score that represents the 75th percentile. So go ahead and take a minute and get this started. That means draw a picture of it. The good thing about Unit 3 is there's only 4 sections. So we can go ahead and get this test out of the way quick. So we got a mean of 100 and a standard deviation of 10. And the 75th percentile is going to be up in here because this is 50. 75th, let's see, 50, that's 84 right there. So half of 84 would be 67. So 67 would be right about there. So let's see, half of 17 is what? 8. 8 plus 67 is 75. So that's going to be right in here. So they want to know what number, what test score right here represents the 75th percentile. So we take our handy dandy calculator and we do second bars, inverse norm, 0.7500, and hit paste. And enter 0.67449. That is, so z-score is 2 digits, so that's 0.67. So 0.67 is right here, but that's not a test score. That's a z-score. So now we got to use Oz plus mu. So x is equal to Oz plus mu, and that's going to be 100 times 0.67 plus, I'm sorry, backwards. The Oz, the sigma is what? 10. Sorry. 10 times 0.67 plus 100. So take your handy dandy calculator and do 10 times 0.67 plus 100. I got 106.7 or 107. 106.7 or 107. And that is the test score that represents the 75th percentile. So as you can see, 7.1 and 7.2 isn't very difficult. Not a lot of math, just using the calculator and drawing a picture. There you go. I would ask if there's any questions, but nobody asked questions in here, so I'll just keep going.
I have a question.
Yes.
Okay, so can you go back over that calculator instructions? You kind of zoomed through them.
Okay. Which part?
Thank you.
Which part, Miss
The whole calculator. The whole calculator. Yeah, all I got was you did second bar,
okay.
Inverse norm, and then I lost you.
That's fine. Thank you. Thank you for asking the question. Be glad to go over it. Now, to find the area, I just assumed that y'all understood how to do this. I'm sorry. Let me go over the calculator. So I'm going to clear everything. And I'm going to clear here also. And your key that you're using for the area is second vars normal CDF. And it's going to ask for a lower bound and an upper bound. And in your case, when it's asking for, in this case right here, your lower bound is 1.3. Because which way do we read, Miss Vincent? Left to right. So that's the lower bound and that's the upper bound. Okay, so I'm going to put lower bound in pink and upper bound in green. Because this is your upper bound and this is your lower bound. Okay, so that's how you use the second vars. Now, you can actually punch in the mean and the standard deviation, but I'm not going to go there yet because I don't want to confuse people. So on your newer calculators, you can actually type in the mean and the standard deviation right here. But I don't do that because some people don't have the newer calculators. So I teach it from a everybody has an old calculator perspective. Now, what if you're given, like here, you were given a percentile. Hold on, let me find it. Well, I can't find it right now, but you were given a percentile, like 75%. Here we go. Here, I was given 75%. If you're given the percent and you got to find a z-score, then you use what's called inverse norm. Second, vars, inverse norm, and you type in 0.7500. Now, the reason I'm using 4 digits is because most of the time 4 digits equals 4 digits equals percentile, or usually 4 decimal points equals area / probability / percent, and 2 decimal points is usually z-score. That's something I tell students whenever I teach this. I always try to let them know that 4 digits usually means area probability. 75.7500, that's an area. So you type in 0.7500 and you just hit paste, and it tells you the z-score. Well, I hit the wrong button. Hold on. Let me get rid of this. Second vars inverse norm there, and type in 0.7500. And most of them are going to be left because we read from left to right, and most of the time they want to know the area to the left, most of the time. And hit paste and enter. And that is the z-score that represents 75%. Once you have the z-score, you plug it into Oz plus mu, which is that formula right there, and it will give you the x. Okay? Does that help a little bit, Ms. Vincent? Okay. Ask and you shall receive. Don't ask, don't cry. Okay, anybody else got a question? All right, let's do another one. Let's do one out of your homework. Let's go to the handy dandy homework and click on 7.2. And all right, try this one. This one's very simple. Now, let me go ahead and tell you, these tables, that's the old way of doing it. I don't show that anymore because everybody uses the calculator. And I just don't see no need in showing it. So we're going to use calculator. So I'm going to blow it up a little bit. I can't blow it up any more than that. I'll write it down on the whiteboard so you can read my writing. Determine the area under the curve at the following z-scores. I don't know if that's what they say, but that's what I'm writing. A is z is equal to 1.36. B is z is equal to negative 1.26. C is 0.03. And D is 0.04. So, of course, you see that this is z-score. That means mean is equal to 0 and the standard deviation is equal to 1. So I'm going to draw a picture. I'm going to have to do colors here because to see everything, we're going to have to do colors. I'm going to transfer these to my graph. 1.36, negative 1.26, 0.03, and 0.04. So here is 1.36. We know that 0 is the mean, standard deviation is 1. And 1.36 is probably about here, because that's 1.5. So that's 1.36. This right here, your number line from second grade, that's negative infinity. That's positive infinity. But we can't type in negative infinity. So we're going to type in negative 9999 or positive 9999, depending on what we need. And in this case, we always need the left. The left is kind of self-explanatory. So that's what they usually want. So I'm going to type in second bars. Let me get my calculator. Second bars, normal CDF, negative 9999 to 1.36. And calculate. And I got 0.9131. So my green is 0.9131. 91%. All right, you try negative 1.26. Since it's negative, we're going to do that in pink. All right, try it out. I'll give you a minute. It shouldn't take longer than a minute. So negative 1.26, and there's 1.5. So 1.25 would be right here. By the empirical rule, that's 2.5, and this would be what? 12 divided by 3 is 4, so that'd be 12, maybe. 13 divided by 4. Yeah. So that'd be around 12. I'd say it's around 0.1400 by the empirical rule. I could be wrong. So let's go ahead and type it in. And it's going to be negative 1.26. And type it in the handy dandy calculator. Second, enter. And I'm going to change this to negative, put an insert, second insert, negative 1.26. I got 0.1038. I said it was going to be around 14%. Came out to be about 10%. So I was a little bit off. So the answer to the pink is 0.1038. 0.1038. So almost 10%, a little bit over 10% is in those pink lines right there. Now let's take our blue line, or blue color. 0.03 is right here. Now somebody tell me common sense wise, what's going to be 0.03? A little bit over what? A little bit over what? If the middle is 50%, what will 0.03 be over?
Around 50%.
It's going to be a little bit over 50%. Thank you. So by the empirical rule, I say it's going to be around 50.5%, maybe. By the empirical rule. I don't have any idea, so let's see. We know this is 0.03. So take our handy dandy calculator. Second, enter. And that's going to be negative 9999 to delete 0.03 and enter 51.20. So right at 0.5120. 0.5120. All right, I'm going to let y'all do the last one. We'll do the last one in orange. You do the last one. 0.04. Which is going to be a little bit past 0.03. I'll exaggerate it a little bit. All you gotta do is change one digit. .5160. 0.5160. Each one of those is a test question. In other words, if I was to give you a question on a test, it would be one of these. I wouldn't give you 4, although they may put one on there with 4. So let's type it in and see what we got. 1.36 is 0.9131. 1.26 is 0.1038. 0.03 is 0.5120. And the last one, 0.04, is 0.5160. See, they're not hard. 0.5160. See if I can find a good one. Let's see. Determine the area. No. I want to find a question that would be on the test. There's one that could be on the test. All right, write that one down. It says find the z-scores find the z-scores that separate the middle 28%, that separate the middle 28% of the distribution from the area in the tails of the standard normal. Okay. From the middle 20 in the tails. And that's the test question. There's going to be several of these on the test. So go ahead, I'm going to give you 2 minutes. So I'm going to put you on timer. Give you 2 minutes. Get it started or finish it. Go ahead. Oh, and I did underline middle there to kind of help you out. You're welcome. Of course, I don't know if it helps you out because y'all don't talk to me, so. As the old saying goes, squeaky door gets the grease. If you don't say anything, then it's your own fault. 0, 1, 2, 3, -1, -2, -3. And you got like 15 seconds left. So 14%. 14%. 50 minus 14 is what, y'all? 46 or 36, right? So this is 36, and this is 36. And we want to know this z-score right here, and this z-score right here. So since it is symmetrical, since these are symmetrical, all we got to find is 1, because this one's going to be the same. So there's 1, So take my inverse norm. So second inverse norm. And I need 0.3600. And left is good. I get negative 0.36. So that's negative 0.36, and this is positive 0.36. So positive and negative 0.36 gives us the middle 28%. So go back to our handy dandy question and type in negative 0.36, negative 0.36, comma, positive 0.36.
Mr. Hubert.
Yeah, you got a question.
Yeah, I do. Where did 0.36 come from?
I did inverse norm right here. Inverse norm.
But I thought well, I meant the 36.
Oh, you meant on the drawing.
Into the inverse norm.
You meant on the drawing.
Yes.
Right here?
Yeah.
Well, what's this side right here? What's the percentage of that 50%. Side?
From 0, it's 50%.
50%, right? You said 50, right? 50%. You got 14 right here. What's 50 minus 14?
36. All right. One more question. Where'd you get 14 from?
I'm sorry, you broke up, Mr. McDonald. What?
Where did you get 14 from?
What's half of 28?
Oh. Yep.
Middle. What does the middle of 28 mean? 14 on one side, 14 what?
On the other side. Thank you.
Yes, sir.
I have a question.
Yes, ma'am.
How do you know whether to use inverse normal or normal CD?
Okay, Ms. Simpson. Okay, I got, how do you know? And then it kind of went garbledy. Do it one more time. What?
How do you know whether to use normal CDF or inverse normal?
Inverse normal, that's a good question. Usually people ask that. Inverse norm is used when you're given an area and you need a z-score. So what do you think normal CDF is, Ms. Simpson? If inverse
need an
norm,
area.
Go ahead, what?
Need an area and given a z
exactly. Score. Given a z-score, find the area. Okay, any other questions? All right, let's move on to another problem. And that is a test question. That's, several of those are going to be on there. Let's go to another test question. I still ain't found the one I wanted yet. There's one, and there's a test question. Find the value of z sub 22. So here they're giving you, Ms. Simpson, they're giving you a z-score, so you got to find the area. Now, wait a minute. Hold on. Yeah. So you would type in you draw a picture of it. I'm not going to use one of my copies, but you would draw a picture of it. You're either going to see a Z sub 22 or a P of 22 or 0.22. And that means that when it's usually 2 digits, that usually means it's a Z-score. So 0.22, there's 0.5. So 0.25 would be right there. So 0.22 would be somebody tell me what they know without a shadow of a doubt about 0.22. It's at least what?
At least 50%.
It's over what? It's over 50%. So this is 50 right here. So you know it's over 50%. So you take your handy dandy normal CDF, and what's this area called down here? That's negative infinity. So that'd be negative 9999. So you're going to type in, which way do we read? Left to right, negative 9999 to 0.22. So normal CDF, second bars, normal CDF, and that's going to be negative 9999 to 0.22. .58706. 0.58706. Round accordingly. Since this is a area, I'm going to round it to 4. 0.5871. And it should be your answer. So let's look at it. 0.58, 0.59. It says round to 2. I disagree with that. 59. I don't ever tell students to round their areas to 2. Okay, I'm going to see what they got. 0.77. The only thing I can think of is they're doing a percentile. Let me do the inverse norm. Inverse norm.
It's because it's you need to use the inverse norm.
Yeah, but the problem with that is, I'll tell you why that's the problem. Because they're not supposed to do that. They're supposed to tell you if you've got a percentage. Let me show you. I don't agree with the book on this. If you've got a percentage, it's supposed to be P sub 0.22, and there you use the inverse norm. Okay? Z sub 0.22 means that your Z-score is 0.22 and you use CDF. I disagree with the book on this. So that's the way it's supposed to be. Because why would you give me a Z-score if that was a percentage? Why would you do that?
So on the test, how are we supposed to do it?
Let me see. Hold on, huh?
So on the test, how are we supposed to do it?
I will put test questions on there. It will not be. It will be correct. Don't worry about that. I'll put test questions on there that ain't stupid. All right. Second bars, inverse norm. If this is correct, it's not correct. Point what? 0.22.
It's sort of correct because it gave me negative 0.77.
Yeah, that's not right. That's not right. You cannot tell a student that I don't know why they're doing that. Let me see if they've got a P in here because they're supposed to have P's. See, there's the P right there. Hold on. Hold on, let me get there. There's the 8th percentile. Hold on. There's a test question in there that does that, but I can't find it right now. Okay, well, for the homework, Miss Simpson, which I disagree with, if you see a z sub 22, then this is your area. Add 2 digits to it. This is what I suggest you do. If they're going to do this, then you add two zeros to it, and that is the area right here, 0.2200. So you're going to do inverse norm, and you're going to type in 0.2200. I do not agree with it, because all my teaching years, that right there is what they, if they give you a percent or a area, they're supposed to give it to you like this, or probability of the probability of being less than 0.2200. And they usually give you 4 digits when they do that. So I do not agree with this question. But that's how you do it. I'm not going to put that one on the test. If I put one on the test like that, it will be like this, Miss Simpson. The one that I saw a while ago. Right here, there's one. I saw one with the percentile. Let me go back. There it is. Or let me just go ahead and do another test question. Let me do, there it is, the 8th percentile. Right there. All right, so got to draw a picture on this one. I'll write it on here so you can see it. It says mean is equal to what? 49, and the standard deviation is equal to 7. Find the 8th percentile, meaning 0.0800. That's the way you write a percentile right there. So we've got 49 in the middle. 49 plus 7 is 56. 56 plus 7 is 63. 63 plus 7 is 70. I guess. I don't know. Let me check. No, that's not right. 6 plus 7 is 63. Yeah. No. Yeah, it is. Y'all check my math. My math sucks when I'm adding those things. That'd be 42. 42 minus 7 is 35. 35 minus 7, I have no idea. 28. Y'all check my numbers. All right, now what? Where's 0.0800? Well, there's 2.5. Half of 13 is what? 7. 7 and 2 is what? 9. So would you say that 8 is somewhere right in there, maybe? Got to use that empirical rule. 0.0800. And they want to know this number here. Well, we got to get a z number first. So inverse norm. Let's use inverse norm to find this area. which is that right there. See, why would I put a Z letter when I'm giving you an area? Why would I do that? That's backwards. If I'm giving you an area, I'm going to give you a P. I'm not going to give you a Z. Okay, so somebody give me inverse norm, I'll just do it. Inverse norm, second, enter. And that's going to be 0.08. And enter. Negative 1.4. Now we use Oz plus mu. And that's going to equal 7 times negative 1.4 plus 49. So 7 times negative 1.4 plus what? 49. And the score that you need is 39.2. So 39.2 is the score that represents the 8th percentile.
That formula you used at the end, where did that come from?
Oz plus mu, it comes from,
Yeah, that one.
Z is equal to X minus X bar over standard deviation, or X minus mu over sigma. If you solve it for X, you get, if you solve this for X right here, you'll get that.
Okay, thank you.
Who's got another question? All right, let's move on. Let's find one that'll make you think. What do y'all think? How about that one? Mean equal to 50. And the standard deviation equal to 7. Find the score that represents the 77th percentile. How much time y'all need? A day and a half? How about 2 minutes? Is that enough? Give y'all 2 minutes.
I don't think I did this right, but I got 55.17.
Well, could be. I'm just very impressed that you tried. Who was that? Was that Daniel's son or Mr. Moore?
No, it was McDonough.
Huh? Who? Oh, Danielson.
McDonough.
Yeah, Karate
No.
Kid. All right.
Oh.
I mean, that headband you wore that day was Karate Kid. I mean, you know. All you needed was a daggum Japanese sun. All right. So we got a mean of 50. So that's going to be 57, 64, 71. Y'all check my math. 50 is going to be what? 43. Oh, I'm really going to suck at this. 36 and 29. Y'all check me. Those look right. Give me a thumbs up if those look right. Thank you. And 77th percentile. Well, this is 50. This is 81. I'm sorry, this is 84. So half would be 67. So 67, half of 7 is 3.5. So 70 is right in here. So I'm going to say 77. Let's see, 70. Is that right? Hold on. Did I do that right? 50 to 84. That's 34. 17 would be 67. So 14, half the 7, that'd be 71. And then 71 to 84, that's not right. I guess it would be right. 71 to 84 is like 13. I still don't think that's right. That's 17. Half of 17 is 8. 8 and 67, 75. There we go. And 77 would be about here. Does everybody agree with me? That should be 0.7700. And that's going to be, we need that z-score, so inverse norm. So second bars, inverse norm, 0.77, and paste, and enter, and quit. I don't know why. Let's see. Didn't like that negative probably. Second entry. Yeah. Inverse norm 0.77. I don't like that negative. Try that. I got 0.73, 0.74. So I've got a z-score 0.74. So Oz plus mu, x is equal to 7 times 0.74 plus 50. And take our handy dandy calculator, and that's going to be 7 times 0.74 plus 50. Sounds like Mr. Miyagi taught you right. X is equal to 55 point what? 18. Good job. So how you feeling?
Can you show your paper again?
Like right here? Talking about that?
Yes, sir. Yes, sir.
Question, gripe, complaint. Okay, y'all have a whole weekend and a week, end of this week and the weekend, to work on these 4 sections in the test. I might give y'all to Tuesday. That way y'all can ask questions, even though I don't think y'all have questions. Let's type it in. I got 55.18. Excelente. All right, how we feel? Good? Okay, what is that, Miss Vincent? What was that? You did this, Miss Vincent. You did like a half of a kind of a week. Okay. Well, I was just assuming that y'all knew this stuff.
That was
that's why. What?
That was like a 75%. Okay.
0.77.
Yeah, like a solid 0.772.
Well, I tell you what I'll do, Miss Vincent, because y'all communicated and y'all let me know that you had some questions. I will take the test and the homework and I'll extend it till Tuesday. That way, if you have questions, you can go over. See what communication does.
Yeah, thank you very much.
You're welcome.
Are you sure you don't want to put those bonus questions back on there too?
No, I think I'll leave them off. Y'all don't need them. Y'all don't need the bonus questions.
Are you sure? Because I think we might.
Nah,
sure?
I think you're okay.
Right. Are you sure?
Yeah, I think y'all are okay. Y'all are adults.
I don't know about that one. Yeah.
Okay.
We might need those bonus questions.
Hold on a second. Let me fix the test before I forget it. All right. 6.1, 6.2, 6.3, 7.1, 7.2, and the test. I'll fix that in just a second. And I think I gave y'all Monday, didn't I? Wait a minute. What's today? Today is the 13th. Yeah, I'm giving y'all the Monday. So I'm still giving y'all time for questions. Let me make sure. Yeah, the 18th. Okay, I'm still giving y'all time for questions. And the test is due on the 18th also. So you'll have time after class to finish the test. All right, let me call the roll and y'all can have the day off.
Feel free to put those bonus questions back in there if you feel like it.
I really don't think y'all need that.